Hello, friends. My name is Dhananjay Singh, and you're looking at my first robot, the Line Follower. Subscribe for a detailed tutorial in a later session. So, let me break down my robot so that you can understand what's going on over here. So, let's start off with the chassis. For those of you that don't know, the chassis is the part of the robot on which is basically the base of the robot on which you put all your software, all your like circuit boards, your breadboards, and whatnot. So let me flip it over. So the main component of my chassis is the wooden base that I have here, and as can be seen, there are two wooden bases, right? The two wooden bases. Other components include the motors, the wheels, the L clamp, the screws, the caster wheel, and yeah, that's about it. Next will be the circuit board. Now, this is the circuit board. You could use an Arduino if you please. However, I have used a Skyfire Labs development board. So, let me break down all the components which will be essential for you when you make your line follower on the circuit board. I mean, so this is the microcontroller. This is an AT89S52 microcontroller. So a microcontroller basically it's like the brain of the robot. It contains all the code. It contains all the yeah, it contains the code. It receives information. It outputs information. Basically controls the robot. It's the brain. And and as for my board, my development board, yours may not be the same, but it has 4 ports on it, which is P0, P1, P P2, and P3. Additionally, it has the microcontroller. It has 4 potentiometers, which basically control the amount of voltage. And on every port there are 8 pins, which all have can have about 1 bit of data. So like each port has 1 byte. Now, one important thing to know about your microcontroller is its clock speed, because you have to sync everything with that, otherwise your robot won't work. As for this microcontroller, the AT89S52 microcontroller, the clock speed is 11.0591 megahertz. So that's important to know while you code the program. Now, other components include a serial port, as can be seen. This is to connect your robot. A reset button. Boy, oh boy, did that give me a lot of trouble. These lights, which are connected to your IR sensors, which I'll be coming to in a bit. And these are the pins to which your batteries are connected. Right? And this is the switch for the batteries. This is the switch for the circuit board. This is the power light, which will come on when the power is on. And yeah, that's all the components that you require to know about at the moment. And as for the most important component, without which your line follower wouldn't quite be a line follower, it's the IR sensor. So an IR sensor stands for infrared sensor. Essentially what it does is, this black sensor over here sends out infrared waves, and these go around everywhere, as you can imagine. And when they strike any sort of dark surface, or any surface actually, they get reflected back, don't they? And when they get reflected back, they're caught by this sensor right here, and this sends the input. I'll show you how it works in a bit. So based on the input that you get from this IR sensor, you can upload a code onto your microcontroller, and your robot will act accordingly. So as for my line follower, when this sensor receives a signal that yeah, there's a black line on my side, see there's one on both sides. When it receives a signal that yeah, there's a black line on my side, my robot will tilt towards that side. Now how will it do so? Supposing my robot is running like this, right, and it catches a black line on this side. So I have configured my code in such a way that in such an event, this wheel will start moving forward and this will move backward. So it will turn, and likewise for that side. Now let me show you how this looks when it's turned on. Oh, and sorry, and these are simple DC motors, if I forgot to mention it earlier. So let me show how it looks when it's switched on. This is how it is, and every time you switch it on you have to reset it, otherwise it just acts really funny. Now if you notice here, there are 4 red lights on. Now what does that mean? As I said before, these sensors are all connected to the IR sensors on the downside, right? So when the IR sensors receive a black or a dark surface, or any sort of surface actually, they send a signal here and these lights come on. As for sensor 1 and 2, they're gonna be on all the time. Sensor 3 and sensor 4 are connected to my IR sensor. So there's a red light. So as for right now, you can see there's a red light on sensor 3 and 4. That means that there's a dark surface underneath both my sensors, which is my brown table over here. Right? Now if I put a white surface like this, you'll notice that they turn off. See? They turn off. And why is that? That's because the white surface is not reflecting any light. Right? So hence the IR sensor doesn't pick up anything. And as for the potentiometers over here, you can tighten them or loosen them with your screwdriver, and they configure the sensitivity of your IR sensors. Like if you reduce the amount of voltage, in this case if you reduce the amount of voltage, then the output voltage to the IR, it will create a threshold. So when light is reflected back to the IR sensor, it creates a sort of voltage, right? So if it's above this threshold voltage, it will send a signal, otherwise it won't. So by virtue of adjusting this threshold, you can control the sensitivity of your robot. So I'll be coming back on how exactly I program my robot in a bit. So I programmed my robot using NuVision Embedded C. So NuVision was the IDE, and Embedded C was the programming language, because the robot doesn't quite understand our usual high-level languages like Java and Python and whatnot. So I had to use Embedded C in this case. And now one doubt that may be in your mind is how exactly I uploaded this onto my development board or my microcontroller. That is using something called a USB ASP programmer, which I'll show you in a bit. Thank you. So this is my USB ASP programmer. As can be seen, it has a USB port over here. So you can just simply plug it onto your computer, and using these 6 wires, which you'll connect to your development board, you can flash on and yes, that's what it's called. You can flash on the code that you've programmed on your computer onto your microcontroller, and once that happens, whatever you have coded will be stored safely on the microcontroller, and the robot will act accordingly. So let me just show you the parts of this USB ASP programmer. So it mainly has 6 pins. My programmer has 6 pins. They're SCK, MISO, VCC, ground, reset, and MOSI. Now, what do these do? So, MISO is master in, slave out. So, in this case, the master device is my USB ASP programmer, and it allows me to flash on my code onto the robot. Next is the VCC. VCC is what supplies power to the robot. So basically, when you flash on your code onto the robot, your robot has to be switched on. So how do you do this? You connect your USB ASP to your computer and the VCC to the robot. So power comes from your computer to your programmer, and from your programmer to your robot. Next is MOSI. That's master out, slave in. So that allows the robot to send. That allows us to retrieve data from the microcontroller on our computers. The GND is the ground, which is self-explanatory. The RST is to reset, and SCK is a system clock, and it's kind of shared between the USB ASP the and the microcontroller, so that you can play around with them and do as you please. So they have to share a common clock speed. So that's using the SCK port. As for the rest, the green resistors here, and yeah, and then the USB port. So your USB ASP is essentially just a medium for you to communicate with your microcontroller. Now, to get into further details, I flashed on my code from my USB ASP to my microcontroller using something called the Prog ISP, which is a program which allows you to connect your USB ASP to your development board. And as I said earlier, I coded in embedded C, and for that I had to download New Vision, Keil New Vision, KEIL New Vision, and I'll put the link in the description, or you can just Google it. It's pretty readily available, and I'll also put my code up in the description for you to view. And coming shortly will be the demonstration of my robot. And yes, thank you. Until next time. This is a line following robot which follows the line as can be seen by virtue of the IR sensors on its underbelly. The IR sensors return a positive value when faced with a black surface. The response of the line follower can be coded, in this case, which is done embedded C. As can be seen, the right light blinks. This is a response from the IR sensor that a black line is found on the right side of the line follower.